4.2. Describe the nature of emissions from the nuclei of atoms as radiation of alpha, beta, and gamma rays in terms of ionizing power, penetrating power, effect of a magnetic field, and effect of electric field. So on this slide here, I've got a table on the right hand side that I'd like you to copy down in your books. The key thing here is in the table is there's both penetration strength and ionization ability. So that's looking at 2 out of the 4 sub-dot points in this 4.2. So what is the properties of alpha, beta and gamma radiation? They all have different charges, different ionizing ability. That is the ability to strip and separate electrons from a material. And they all have different penetrating abilities. So as I mentioned, the table on the right summarizes this. So an alpha particle has a charge of a +2, a beta particle has a charge of -1, and a gamma particle has no charge. So from penetration strength, it goes from left to right. So alpha is the lowest penetration, beta is medium penetration and can be stopped by air, while gamma is a high penetration and can penetrate several layers of lead or centimeters of lead. Ionization ability is the ability to strip electrons off materials. So it starts from the highest from the left to the right. So the highest is an alpha particle, then beta, then gamma. So this slide continues to our next slide, and the next slide looks like this. So distinguishing between alpha, beta and gamma radiation between a magnetic and electric field is on this slide. So it is possible to distinguish between all 3 particles by passing it through an electric or magnetic field. The diagrams below show the effects of alpha, beta and gamma radiation as a pass through a uniform electric field and a magnetic field, and you can see that there. So these diagrams and the tables are key to understanding the nature of emissions of atoms as radiation of alpha, beta and gamma radiation. The 2 inserted diagrams of the table and the diagram are key to understanding this.